draw this line, it would be our actual inclination with the vertical plane. It would be actual inclination with the vertical plane as well as the true length. Now if we talk about the top view, in this sketch the top view is rotated and made parallel to the XY line. Because of this we have got the true length as well as the true inclination with the horizontal plane. I am repeating once again, if we want to have the true length and the true inclination with the HP, what we can do? We know what is the front view and what is the top view. We have got the front view line over here like this. We have got top view line over like this. In the top view line, taken radius as AB. Taken radius as AB. Take A as center point and mark a arc till line parallel to XY line but passing through point number A. Then from this point I have named is at point number B1, and from this point I have drawn a perpendicular line to B dash parallel line, named it as B1 dash. I will join B1 dash to A dash. This would be our true length. If we measure this angle with the protractor, then this would be the true inclination with the horizontal plane. Now what if we want to find out the true inclination with the vertical plane? We know the true length and we know how to look at front view and top view. This is our true length and we have got the angle. The same thing of this we are extending. We are just extending this problem itself. I have just drawn A dash and B1 dash, the red line. I have just drawn this red line over here like this. We have got the actual inclination with the horizontal plane as well as the true length. Now what I will do? We are having this length also over here, the angle phi as well. Always mark these parallel lines. There will be 4 parallel lines to the XY line. First, second, third and the fourth. These 4 parallel lines should always there in your projections of line. Like this would be the thing. Now we are wanting the front view and the top view. What I have done, I have just extend this line perpendicular to this point. Now what I am going to do, I will just mark this point as B2 dash and have A dash B2 dash as radius, A dash as center and draw a arc which cuts B1 dash parallel line. Repeating once again, A dash to B2 dash, draw a arc which cuts the B1 dash line. Now at that point we have got B dash, which means that we have got the front view. Now we will extend the front view itself till B2 parallel line. Always front view and the top view would be in the same line only. So what I have done, I have just dropped down the shadow of the front view like this till the B2 point. like this. Now from the true length, what I am going to do, from this true length of the vertical plane B1 dash, I have dropped down the shadow till B1 and A B1 as radius, A as center, and mark a arc which in any case will cut down the B point, which would be on the B2 parallel line itself. Join the line and you have got your top view as well as the angle of the projection of line with the top view. Here A dash B1 dash is component of true length AB1, and we can similarly draw the true length if A dash B1 dash has been given. Very simple, isn't it? Now this is the most important diagram showing the graphical relation among all important parameter of this topic. You see clearly and memorize each of the part and have clear idea how you can have the projections of any sort of line. This is our vertical plane. Always remember in mind that we have just unfolded horizontal plane and vertical plane into the straight line. So horizontal plane and the vertical plane would be in a straight line itself. The XY line would be differentiating the horizontal and vertical plane. Above XY line always would be vertical plane VP. Below XY line always HP component would be there. Now what is important thing? The first one is this A dash to B1 dash. A dash to B1 dash is true length. As you can see over here, true length, which means the actual length. A dash to B1 dash. A dash to B1 dash is true length. Also A and B1, A and B1 are also true length. The red line showing true length in the horizontal plane and the blue line in the vertical plane shows the true length. Now angle with the true length, angle with the HP, as you can see over here, this angle with HP, angle with HP always shown in the top vertical plane. As you can see over here, this angle denominated as alpha, angle with the horizontal plane. Angle with the vertical plane over here, this angle with the vertical plane phi is shown like this. The angle of front view with the XY line, not with the true length, angle of the front view with the XY line denominated by this. It is called alpha 1. This is called alpha 1 angle. A dash B dash angle with the XY line. A dash B dash angle with the XY line is called as alpha 1. Angle of top view with the XY line. Angle of the top view with the XY line, which means that the angle of the top view, this view, AB, the angle of AB with the XY line, called as beta 1, called as beta 1. Next one is length of front view. Length of front view, the length of this A dash B dash and length of this AB. In some of the problem you might be given the length of front view and the top view, and in some of the problem you might have to find out these kind of lengths. As well as we need to have the distance between two projectors. As you can see over here, the distance between two projectors shows what? The distance between the front view component and the top view component, like this. The horizontal distance between front view and the top view component. Horizontal distance between A dash B dash as well as AB. In some problem you have been given the example like this. The point number A is 50 mm above HP and 25 mm below X in front of VP. Point B is 25 mm above HP and 50 mm behind VP, and distance between two projector is like this. So at that time you need to know the projections of point as well as you need to know the distance between two projectors. Now if you see that true length never get rotated, it is a horizontal component and it is further rotated to locate any sort of view. Only views would be rotated. Only from the views we will take the arc. One more thing you need to remember, that these kind of problem may be asked in the exam very frequently and you need to have practice of it. Front view and the top view component will always lying on the same parameter. If the front view is having the length of 50 mm, then if we take the projection downward, then it would be in the same line itself. In the next lecture we will see the proper animated videos from the Cognifront software which have clearly customized for the GTU students only, and from this we can have brief idea how you can project various line using various cases. Basically these 5 cases would be there, but the style to be asked in the exam differs. In the next part of lecture we will see the example solved so that you can clear have idea about this. For this lecture, that's all. Thank you very much.